Okay, welcome to the Project 1 tutorial video. I will be going over a fairly simple example of converting a Boolean equation to gate form, to a circuit. So the equation that we are given is f equals a and b naught, or b and c. So for this, we can see here that we're going to need two AND gates, an OR gate, and a NOT gate. So I'll just put this off to the side here. Okay, so I already went ahead and started a new project. If you're unfamiliar with how to do this, watch the SIDSI Virtual Lab video that will go over all this introductory stuff. So we're going to go to Project, create a new source, make it a schematic. We'll call it schema, but you're going to want to use the naming conventions that we give you. So that would be your ASU right, ID, underscore, and then whatever project name and the deliverable name is. We'll always give it to you. So let's go ahead and get started. Click on symbols. We'll filter these symbols out by ANDs. Double click so we can place multiple ones down, and we don't have to click and hold. So click one down, click second one down, escape. Then we will zoom the box because this is a little distant. Alright, that looks pretty good. So right now we got our two ANDs right here. So let's go ahead and get our OR while we're at it. So we'll filter by OR. I want two inputs. Place that right about there. Looks pretty good. So now we need our NOT for this B. So I'm going to put it right here on my top AND gate. Now the word for NOT in here is INV, which as you may be able to guess is short for inverter. So let's go ahead and put our markers down. So this will be our A, this will be our B, and this will be our C. I'm not connecting anything to this quite yet, so we'll be drawing a wire up here in a second. So let's double click on the marker name. I'll click down here under nets and name this to A. Same thing here, call this one B. Move over a little bit. Oh my. So we'll click this one here, and this will be our C. I'll click OK. So let's drag this marker out a little bit. So we've got, I don't know, too far. So we've got some wire to work with or to connect. I'm going to add a wire, and we'll click here after we see the four squares. We will connect that to this B wire for the BC. So we want to add one final marker on the output of our OR gate. call this one F. And we will add the wires and connect this OR to these two ANDs, thus satisfying our equation. So, going to want to save. Always save before you create your test bench, otherwise it will either not be populated with anything or not be fully populated. So, save often. So now we'll go back up to Project, New Source, Verilog Test Fixture, call it Test Bench, just for this instance. You will need to follow the naming conventions. So we want to associate it to our schematic. Mine is called schema. Yes. Okay. Now get rid of this if, def, auto, init, and if. So let's go ahead and put a delay of 100 milliseconds to initialize. So, one thing I'm going to show you today is the monitor. Now this enables you to get a textual output on the console. So it's kind of like a print line or a print in your regular software languages. So the syntax for this is $, oops, I'm going to type today, $monitor, it'll turn yellow, left parenthesis, and then you enter a string for what you want to be displayed. So we're going to say A equals, and then I like to put my outputs inside of parentheses. I think it just makes it look a little cleaner. But we are going to be displaying this in binary, so the syntax for that is %b. I believe there's also hexadecimal and integer, and I'm sure there are others, but I mostly just use binary. So we'll say b equals %b, c equals %b, and our output f equals %b. And I held shift down. Haha. So then we will end our quotes to terminate that string. I'm going to put a comma in, and then after this we enter our inputs in the order that we want them displayed. So that would be A, comma B, comma C, comma F, and close parentheses and semicolon. So now we are going to want to copy this, I do anyways, so I don't have to type everything down. If you would like to, go ahead. It's good practice. Okay, I think that should be enough. Okay, so let's go ahead and start counting in binary. So we have our 0, 0, 0 up here. So let's start 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and I have 2. Oops. 1, 1, 1, 1. Now we want to put an end, because that is where we want it to stop. Go ahead and save. And now we are going to run this and make sure everything works. So make sure you are on the simulation view. Click on the Verilog file associated with your schematic. We'll check the syntax, make sure that we got everything typed in correctly. Alright, that looks good. So now we will simulate. Let it do its thing. Okay, and here we have a nice output down here. Looks kind of like a truth table, so pretty easy to read and understand exactly how your circuit is behaving. Now this doesn't look like too much because this circuit ended a long time ago. So we're going to click zoom to full view so you can actually see some of the behavior here. Now if you click, you can drag along here, drag along the timing, and see how the circuit is changing over here in this left pane. Okay. And this concludes the tutorial for Project 1. I hope that this has given you guys at least somewhere to start for completing Project 1. If you have any questions, feel free to ask in the forum, the Project 1 questions. I check it a few times a day, so I'll try to be as prompt as I can in responding to any issues that you have. Alright, good luck everyone.